Rich Cangemi here with Brandon Petty. He's with ICFICF. He's basically handling this bill block installation for us, and we thought we'd talk to you a little bit about maybe some of the challenges here with this type of an installation. I took a call about a week ago from a guy who was thinking about doing this kind of work himself, and as you can see here, we hired a professional. He's done, I don't know, more than a dozen of these, right?
Close to 100.
Close to 100 of these installations. So there are some tricks, and we don't want you to give up all your secrets, but perhaps you could tell us a little bit about what we're doing here.
The biggest secret is to have the proper bracing to get the walls straight. A lot of homeowners don't brace properly. They just use 2x4s and stuff, and then you get wavy walls. Concrete pouring is the most critical part of the job, and that's where you have the most problems. So the bracing is a key component to this, and it's quite costly for a homeowner to do this kind of work by himself because of the cost of the bracing. So that's probably the biggest challenge.
What do you like about this particular block system? Does it fit well together? Are there differences between the
There are differences. Probably the best feature about this one is it's reversible, so you don't have lefts and rights, and for corners and stuff. So when you get to the top, if it wasn't reversible, if you're short one right corner, then you're screwed. You have to make it or order one block. So it's a good block. We've never had any blowouts with it. No issues.
When you're doing, it looks like we got reinforcements running vertically here. So we've got the rebar kind of running vertically, and you guys also set rebar horizontally as well. And then around the windows, we've got the vertical rebars. We've used a kind of a bracing system here that these guys supply, which is kind of the advantage of using a specialist, is that they're going to come with most of these materials that we don't have to buy. So when we did blocking around the windows, Brandon and his crew supplied all the scaffolding, and they also supplied these V-braces so we can get this bucking installed here for the window openings. But specifically on these windows, you've got kind of one running vertically around these, and then we also have the horizontals, which are interrupted at these junctions as well, right?
Yeah, basically we got one bar on each side of the windows, and then underneath the window and over top of the window we got one bar 2 feet past each side to prevent cracking.
So one of the things these guys do is they actually use, and we don't have one to show you, and that's probably a good thing. They use a different form of a reinforcement system over the windows that it's pretty neat, and they have an actual bender here on site that makes this a very straightforward, very expensive machine, but makes it a very straightforward process. So doing these reinforcements over the window and door openings looks pretty easy, but and here's what we're looking at. So this basic system is the stirrup, and this just makes a big difference when we do these installations. We have some really big openings here. If you look at the one in the back, that opening required some really special reinforcement, but very tall stirrup, which has to be precisely made so it fits between all of the plastic ties in the block system, and I think that was 36 inches deep. So if you didn't make it right, it just won't fit, and that has to actually overlap 2 feet in each direction. So a lot of work, kind of neat to watch it. It looks easy when they're doing it, but they've done it, over 100 times, so that's a big part of it. Anything else that you might steer somebody away from, or steer them in the right direction with something like a project like this? I mean, is the height of the walls a big issue with this? I mean, we're getting into almost 13 feet here, so.
Typically, we like to stay around 12, 14 at the max on the first pour. Any taller than that, and you need even more special bracing than what we have here, you need a tall wall system. So it can be poured, but you're talking more expensive equipment, which we do have, but we don't use it on shorter type applications.
Now, when we go through, we're about to pump this wall here shortly, as soon as the concrete and the pump arrives. What is you're going to go ahead and pump this in a couple of different lifts, right?
Generally, we start out with about 2 feet, and we'll go all the way around the project, and then by the time we get to the point where we started, the concrete has hardened up enough to where we'll pour probably 2 more feet. And then the taller we get on there, the more we pour. So the higher we start getting in about 3 feet. We should go around this one probably about 5-6 times.
And how do we make sure, one of the problems with ICFs, and at least in the past, has been the consolidation issues that some contractors have had. How do you guys ensure that we're going to get good consolidation under the windows and around the door openings and pretty much throughout the entire wall system? What are you guys going to do?
Under the windows, we've drilled holes to make sure that we can see the concrete come into the opening. We also have a vibrator that we will vibrate the walls, the steel basically, and it consolidates pretty good.
Awesome. And the slump of the concrete, is that important?
Yeah, we're going to run probably about a 6 slump on that. We want it a little fluid, but we don't want it too wet, because that can create issues with walls expanding. So 6 is about the magic number.
Thanks, Brendan. Let's take a look at that beam back here. So what we're looking at here is this poured-in-place section, which is partially done in a product called Power Steel. We've got all that wrapped. If you look at those corners, you'll see on both sides, you'll be able to see that Power Steel beam. Essentially all that is that's a container for us to pour this concrete, and that's also going to help us do the forming on the bottom portion of the beam. It's been reinforced, so we don't have an issue with holding the weight of the concrete during the pour. And that's that area where we've got to support this third floor. So there's a block, the build block product will be placed on top of that solid poured wall. So we've got some weight up here. So this is actually a 42-inch concrete beam with reinforcement. It's got 2 bars in the bottom, 2 bars in the top, stirrups through, and I believe there's another horizontal bottom bar in the middle. So pretty strong beam, all done within this product with that Power Steel product. Basically a cast-in-place beam. So pretty neat way to do it. Bracing is real important in a situation like this because we don't want it to move. It has to be plumb. It's got to be straight. And it's got to be strong. So, knowing how to do this and the right way to execute it is really important. This is an area where experience counts. Something like this, if not done right and it blows out, is a catastrophe. So you really do need to know what you're doing. So in cases like this, knowing the proper spans, knowing the proper reinforcement, the distance between these reinforcements is important. We've got about 300 pounds for every couple of feet here. So each one of these is going to be holding, somewhere in the order of 400 to 600 pounds of concrete at least. So it's important to get this braced off properly.